Algebra 1, lesson 7.6. So, you're taking notes. So, Algebra 1, 7.6, factoring ax squared plus bx plus c. You should put your name on here, put the date, put the period. And we're continuing factoring, which we've been doing for a couple sections now. Try and get this, show the paper better. All right. Zoom in a little bit. Yes. Okay. So the big difference is last time, this A was always 1, which makes it a little easier, but we're going to use the same steps, okay? So this isn't going to be a 1 all the time now. And the steps we're going to take is we're always going to look for the GCF first. And when there's a 1 there, GCF isn't really an issue. But by getting the GCF, the greatest common factor, it's easier and quicker. It just makes it nicer. Okay, but after we do that, if it has one other than 1, we're going to find the numbers that multiply to get the first term. So the A, x squared. We're going to figure out the pairs of numbers that multiply to get the last term. And then we're going to kind of mess with them to make sure they add up to the middle term. So that's exactly what we did before, but there's probably going to be more options this time. So it's going to be a little, it's kind of a guess and check, trial and error. Might have to do a little more this time to get the right answer. Okay, so let's do some examples and kind of like feel out some different situations. So example 1, the directions will be to factor, which will be pretty much all the problems. And well, what on these ones, we're going to factor out the GCF first. Now remember, GCF is greatest common factor. So greatest would be biggest. Common means they all have it. And factor is something you multiply out. So I'm trying to get this to focus. Seems a little blurry. That's better. Okay. So example A is going to be 5x squared plus 15x plus 10. And example B will be 3x squared plus 3x minus 6. Now, look at this and say, is there something we could divide out of all these terms? Or something that makes all these terms happen? And that's GCF. And so the GCF is, I could take a 5 out of all those. I could divide a 5 out of them. How about an x? That one doesn't have an x. 5 is the biggest thing we could divide out of all of those. So we're going to divide it out. We're going to undistribute it, essentially put it out front. Divide a 5 out of that. There's x squared left. Divide a 5 out of that. There's a 3x. Divide a 5 out of that. There's a 2. And there's a 5 there. But there's parentheses. So we're like, factoring, all this factoring is unmultiplying. So we're kind of undistributing. Now what's left here has a 1 in front, which means it's just like last week, so it should be a little easier. You're going to write all the pairs of factors that multiply to get x squared. So that's just going to be x and x. Then you go to the last term. You can say, well, what are all the pairs of numbers that give you 2? Well, 1 times 2. That's it. And then we want to make sure that if we multiply these together, we get what's in the middle. So x and 1 is 1x. X and 2 is going to give you 2x, which would add to 3x. So that's good. This is the pair we want. This is the pair we want, hopefully, because there are no other pairs. So we're going to rewrite it into the binomials now. So that was a trinomial. Now these are binomials, and these will be at the beginning of each of them. And then these are going to be at the ends. And since these are both 1, it really doesn't matter where we put them. We put it here and here. Now this is a 1x. This is a 2x. They need to add up to 3x positive. So they're both got to be positive, which gives you the sign that you put in between these, the operation. Now we always want to double check that this times this equals this. This times this equals this. 1 times 2 equals 2. That's good. So we found the answer. I'm going to rewrite it. Don't leave the 5 out. That's part of your answer. Don't let it disappear. It's an easy thing to do, even if you don't mean to. Okay? Now, why don't you guys try this one? So pause the video and try this one on your own. Just see how you do. This is very similar to this one. Unpause it, check your answer. Okay, assuming that you've tried it, this one has a GCF of 3. We can take a 3 out of everything here. If we divide it out, we have an x squared plus an x minus 2 left. Now we're going to find the pairs of numbers x times x. How do you get 2? 1 times 2. Now hopefully we can get a 1x, and you can write the 1 there if you want, just to kind of remind yourself, we're looking for 1x. So if we do x times 1, that's 1x, and x times 2 is 2x. Now if you just add these, you get 3x, but if you subtract 1, if 1's positive, 1's negative, which is going to have to happen because of that negative, then I think we could get 1x, right? So let's write it. It should still have a 3. Write the binomials. So there's going to be an x and an x, and then a 1 and a 2. And if we multiply these together, you get 1x. If we multiply these together, you get 2x. And these need to add up to positive 1x. Well, for that to happen, this one has to be positive, and that one has to be negative, right? And that tells you, oh, well, the negative goes here with the 1. Positive goes here with that. And you can double check it. Negative 1 times 2 is negative 2. Check, check, check. Okay, so we got it. Don't forget the 3. X minus 1, x plus 2. So this is just like the work we've been doing last week. It's challenging. Okay, so let's go on to some different problems. Example 2. So I'm really just going to show you different situations here. So part A is going to be 4x squared plus 13x plus 3. And part B is going to be 3x squared minus 7x plus 2. So this time we look for the GCF. We always check for the GCF first, but is there a number we could divide out of 4, 13, and 3? Nope. So this one has no GCF. I mean, technically the GCF is 1, but it just can't do anything with it, right? Okay, but the process doesn't change. Okay, process doesn't change. So now this is where it's going to get a little different than what we've seen before. What are all the pairs to give you 4x squared? Well, it could be 4x and 1x. It could be 2x and 2x, but those are all the pairs. When we go over here, we do the same thing. What are all the pairs that give you 3? 1 times 3 is the only pair. Now we're hoping to pick a pair here and a pair here that work together to give us 13 in the middle. So like if we did this, we did, okay, well, 4x and 3x. Could you get 13x from that? No. But here, the order matters, so we could flip them around. So we could do 4x times 3 is 12x, and 1x times 1 is 1x. Could we get 13x from that? Looks like we could. Now, by the way, if we did the 2's, it'd be 2x and 6x, and there's no way we're getting 13x from that. Right, so I think it's got to be this one, okay? So then when we rewrite it, there is no GCF this time. We're going to have a 4x and a 1x. All right, so, sorry, let's step away for a second. Okay, so now we're going to put the 1 and the 3, and it does matter. Now it matters. When there's not just ones in front, when there's not just a 1 in front, now the order matters. It didn't really matter before where you put the 1 here, the 3 here, 3 here. Remember, we want to get 12x and 1x to give us 13x. So the 3 has to be over here because that gives you the 12x, right? And the 1 has to be here, and that gives you the 1x. And that's how we're going to get 13x. Now, it's got to be positive, so they're both going to be positive, so we can get pluses here and here. Check the last numbers. 1 times 3 is 3. So we found it. 4x plus 1 and x plus 3. Usually you don't put the 1 in front in your final answer. Now, if you would put these in the wrong spot, that's fine. Just change it when you realize it doesn't work. Okay? All right, next one. I want you guys to try this one. So pause the video and try it, and then let's check the answer. This is your best bet. This is where you're going to figure out if you really know how to do this. If you just watch me do them over and over again and be like, oh, okay, that makes sense, you're not going to be able to do them on your own. You got to test yourself right now and then see me do it and figure out what's going on. So try it and pause it. Okay, assuming you've tried this already. Now, first thing we look for the GCF. There is no GCF. That's fine. It makes it easy. If there was one, you want to take it out, though, at the beginning. So we want to find the pairs of numbers that give you 3x squared. So that's going to be 3x and 1x. That's the only possibility. And then to get 2, it's going to be 1 and 2, right? Now, we want to somehow get a 7x in the middle. So if I do 3x and 1, that's going to be 3x. And I do 1x and 2, that's 2x. Can I get 7 from that? No. But remember, we can switch the order. So we can do 3x and 2 is 6x, and 1x and 1 is 1x, and that would give us the 7x, right? So we can do it. And this is that's our only shot. So we're going to write the 3x and the 1x, right? The binomials. Now, it matters where we put the 1 and the 2. Remember, we want to get a 6x, so we got to put the 2 here, because it gives you a 6x, and the 1 here, because that gives you the 1x. And they need to add up to 7x. Now, negative 7x, right? So that means they both got to be negative, which means you're going to put negatives here and here. Negative 1 times negative 2 is positive 2. Checks. So that's our answer. Now, we're not going to usually write that 1 in front of the x for our final answers. It's okay in your work. All right. Let's do some more. Example 3. So example 3, it's just going to be some more of these. 2x squared minus 5x minus 7. And for part B, we're going to do 3x squared plus 5x minus 2. So let's try these out. Now, first thing we do is check for the GCF. No GCF. Believe me, though, if there was, you want to take it out because it for sure makes things easier. So you don't want to just be, whatever. How many ways to get 2x squared? 2x times 1x, only way. How many ways to get 7? 1 times 7, only way, right? So, okay, it's got to be this and this, hopefully. Well, let's see if we can get that 5x. So if I do the 2x and the 1x, I get 2x, and the 1x and 7x, I get 7x. And I think I could get 5x from these if one was positive, one was negative. If we did it the other way, if we did the 2x and the 7, we get 14x, and the 1x and the 1, we get 1x. There's no way we're getting 5 from that. So the order is going to matter, but I think we see the possibility there. So we're going to write our binomials. Now, where do we put the 1 and the 7? We want to get the 2x and the 7x. So if we put the 7 here, that gives us 7x, and the 1 here gives us 2x. If you put the 7 here, you get 14x. You'd be like, oh, no, that's not going to work. That's fine. Just try it out. Be okay with trying it. Now, we want to get negative 5x. So this one's got to be negative. That one's got to be positive. So that means this is negative, and that's positive. Negative 7 times positive 1 is negative 7. That checks. You could fully check your answer by foiling it out and seeing if you get what you started with, the whole thing. You could totally check the whole thing. Okay. I want you guys to pause the video and try this one on your own. Okay? All right, assuming that you've tried it, we look at it, there is no GCF. Okay. All right, that's fine. So pair of numbers that multiply together get 3x squared. Well, that's 3x and 1x. That's the only possibility. Or you could say 1x and 3x, whatever. How about 2? 1 times 2. Only possibility. So this is our only shot. It is possible, by the way. I'm probably not going to give you any of these yet, that we might not be able to factor it because we can't get any pairs that work. But for now, you should probably count on always having a pair. So we want to get a 5x. So we get 3x in the 1, we get 3x. And the 1x and the 2, we get 2x. And we think, oh, yeah, that's it. That's the 5x. Yeah, but one of these is going to end up having to be positive, one's going to be negative. So it's probably not going to be that, actually. So if I switch up, I do the 3 times the 2, I get 6x. And the 1x times 1, I get 1x. This is actually the one that we're going to be using to give us the positive 5x in the middle. So I could see some people thinking that first one was going to work. But all right, so we get 3x and 1x. And it matters where we put it. So I think we want to put the 2 here to get the 6x. And the 1 here to get the 1x because we need them to add up to 5x, but we know they got to give us a negative here. So 1's got to be negative. So this is going to be negative. That one's going to be positive. Negative, positive. Now double check. Negative 1 times 2 is negative 2. Now if you had accidentally done the positive 1, the positive 2 here, the positive 1 here, you would have checked it and realized that there was something wrong. These signs matter. Okay? So it's going to be 3x minus 1 and x plus 2. All right. Okay. Let's add something new to it. Okay. So example 4, we're gonna add a new little twist to it, and actually this is a pretty easy thing to deal with to get back to what we've been doing. So factoring when a is negative. When a is negative. So I'm going to show you what I mean. So example A, I'm going to leave a little space right here. Negative 4x squared minus 8x plus 5. Okay, and then example B is going to be negative 2x squared minus 5x minus 3. Now here, the big difference in these problems compared to all the other problems that we've done is the negative in the front. The A, that's the A right there. Okay, so here's the easiest way to deal with this. Okay, easiest if you factor out a negative GCF right from the beginning. Okay, factor it out. Now here's the deal. If you look at GCF for this, you'd be like, oh, there is no GCF. But remember, 1 could be the GCF. This negative, I want to factor a negative 1 out of everything. Okay, now factoring is just dividing. If I divide negative 4x squared by negative 1, I get positive 4x squared. If I divide negative 8x by negative 1, I get positive 8x. If I divide positive 5 by negative 1, I get minus 5. So the thing is, it just changes all the signs. Okay, it changes all the pluses and minuses, and you could make sure, check it. Negative is positive, negative is positive, positive is negative. Now we don't lose this negative term because I think that's even easier to lose. But now we're going to try and factor what's left inside. Now this being positive at the front makes it easier. Okay, so how can we get 4x squared? Well, we could do 4x times 1x, or we could do 2x times 2x. Right? How do we get 5? Well, 1 times 5. That's it. Now we're going to have to get a positive 8x in the middle. We know one is going to be plus or minus, so it's going to be really two things that we're going to take one away from the other to get the 8x. We could try it. 4x and 1 is 4x. 1x and 5 is 5x. There's no way we're getting 8x from that. Well, how about if we switch the order? Remember, we can switch order. How about the 4x times the 5? 20x. 1x times 1 is 1x. Well, no way we're getting 8x from that. So I think that one's out. How about this one? 2x and 10x. And if you switch the order, it's going to be 10x and 2x. It's going to be the same because these are the same. But I think we can get 8x from this. So it's going to be this pair and this pair. So we're going to rewrite it. Don't forget the negative in front. And we're not going to write the 1 anymore. We're just going to write a negative sign. 2x and 2x. And because they're both 2x and 2x, it doesn't matter the order anymore. Because you put the 1 here, it's going to be a 2x, right? Put the 1 here, it's going to be a 2x. So we get that. We want it to add up to positive 8x. So this one's got to be positive. This one's got to be negative. So this one's negative, right? That's where that comes from. This one's positive. You double check it. Negative 1 times 5 is negative 5. And then you multiply the negative by that, and you get back to where we start with. So it's going to be negative 2x minus 1, 2x plus 5. That's your answer. Don't forget the negative in front. Okay, let's try one more like that. We're getting close to done. I got one more example after this just to kind of show you how we can use it on kind of a more complicated problem. There's a negative in front. Now check for the GCF. If there's anything else you could pull out with a negative, you should take that out right now too. And it doesn't matter. You might be like, oh, but they don't all have a negative, so I can't make the GCF. You can divide a negative out of everything anytime you want. If it's positive, it doesn't matter. It's going to become negative. So we're going to take a negative 1 out. It's going to change that to positive 2x squared. It's going to change that to positive 5x, and then it's going to change that to positive 3. Right? If you divide all these out by negative 1, they become positive. Then we're going to look for the pairs of numbers. How can I get 2x squared? Well, 2x and 1x is the only way. How do I get 3? 1 times 3, only way. I want to get a 5x. We could see and make sure it's going to work. The 2x and the 1 is 2x. The 1x and the 3 is 3x. Since it's positive, they could both be positive, and we get. I think that's it. I mean, alternatively, you could do 2x and 3 is 6x. The 1x and the 1 is 1x, and that could be a possibility on the problem. So we're going to get 2x and 1x for sure. Now, where we put the 1 and 3 matters. We want a positive when we're done. We want to multiply together to get a positive. So I think we'll put the 3 here and the 1 here. If you mess up and put them in the wrong spot, then consider just switching them and try it that way. So 3x and 2x needs to add up to 5x. It's positive. They got to both be positive. Check your answer. Positive 3 times positive 1 is positive 3. If that sign doesn't work, then something's wrong. So it's going to be negative. We're not going to write the 1 for our final answer. Plus 3 times x, not 1x. Again, we don't need those 1s. So usually your final answers, we want to be as simple as possible. Okay, last example, and this one's, we're going to use the same ideas, but we're going to apply it to kind of a new kind of problem. So the directions on this problem are going to be find the x-coordinate, should make you think of graphing, the x-coordinate of the points where the graph crosses the x-axis. So we're talking about graph. They're going to give you a graph. So let's draw the graph right here. And then we'll kind of understand. This graph would be given to you, but you could draw it on your homework, just to have it. Okay, now the graph of this, it's going to look like a parabola, okay? And we're going to get an equation that looks like the equations that we've been having our problems. Okay, so this is a parabola. This is the equation of that graph. Y equals 2x squared minus 3x minus 35. We want to find the x-coordinate of the points where the graph crosses the x-axis. This is the x-axis. So we're trying to find information about these points. In other words, those are also called x-intercepts or roots. Those are all we might hear solutions, roots, x-intercepts being thrown around. Okay? So how we're going to do that, here's our strategy. We're going to set it equal to 0 first, because we know along the x-axis, what's the y-coordinate? The y-coordinate is up and down, right? What's the y value anytime you're on the x-axis? What's the height, above or below it? Since y equals 0 on the x-axis, right? So we're going to set it equals 0. So I'm going to actually replace the y with 0, and I'm going to rewrite it. Okay? So that's first set to 0. Now, this problem looks like problems that we've seen in recent sections where it's an equation equal to 0. We could solve it. We could use the zero product property, but we have to factor it. Okay? So the next major step is we got to factor it. Okay? Now, we might have to use any of the strategies we've been doing. There's still a 0 there. GCF, no GCF. If there was a 1 in front here, things would be easier. I guess I'm not going to write that yet. What are all the pairs that give you 2x squared? 2x and 1x. What are all the pairs that give you 35? 1 times 35 or 5 times 7? Those are the only pairs. Now, I need to get a 3x in the middle. So if I do this one, it's going to be 2x and 35x. No way. Okay, what if I switch the order? If I did the 2 times 30, it would be 70x plus and 1x. No way. You're not getting 3 from that. So it's probably not that one. Let's try this one. This one would be 10x and 7x. That looks good. If I switch the order, it'd be 14x and 5x, which is not going to work. So I think it's going to be this. But there's our pairs. So we're going to rewrite it. 2x and 1x. We'll write the binomials. Now, it matters where we put the 5 and the 7. Because if we put it in a certain spot, we're going to get 14 and 5. That's not going to give us 3. So we want the 7 to be here and the 5 to be here, so that it gives us 7x and 10x. Now, if you put the 5 here and 7 here, and you tried it, you'd be like, nah, it's not going to work, and you just erase them and put them in, switch them. Now, we want to get negative 3x. Well, the big one's got to be negative then, right? To end up with a negative, and this one has to be positive. So this is going to be your positive. That's going to be your negative. Check it. 7 times negative 5 is negative 35. Okay. Now, we've factored it, okay? And we've set it equal to 0. So now we're going to use what we've used before called the zero product property. And zero product property is a simple idea that I think makes a lot of sense. It says if you're multiplying things together and you get 0, one of them has to be 0. They could both be 0, but one or the other has to be 0. So what we do is we set each of them equal to 0 on their own. Okay? You guys remember doing this? And then we solve them. So to get x by itself, get rid of addition and subtraction first. Then we get rid of multiplication and division. So to get rid of the times 2, we divide by 2. And one of your answers is negative 7 over 2, which is also negative 3.5 or negative 3.5. Now, I personally would be open to any of those answers. Any of those, it's all the same answer. I'm not really sure what big ideas is going to require, and it might be easiest to type negative 3.5 in, right? Having the type fractions is probably hard. We got to do this one too, right? And it makes sense because if you look at the picture, there's 2 answers. So you shouldn't only get one answer. Now, the negative one is clearly over here on the left-hand side, right? And the positive one's got to be over here on the positive side. But these are the solutions, we might say. These are the roots, we might call it. Or in terms of graphing, we might think of them as the x-intercepts of the function. Okay, but those are your 2 answers. Now, today's assignment, in-class assignment, monitoring progress. In section 7.6, starts on the first page of the section, page 393. It's at the bottom of the pages. We're going to do 1 through 9 all. So at the bottom of each page, there's 1 or 2 problems. Try them. There's a little blue arrow button if you're using the dynamic ebook online for big ideas. You got to be zoomed all the way out to use the arrows, but I recommend all of you on these ones use play after you try the problem, do the blue arrow. It's a video showing you exactly how to do the problem just to make sure you're doing right, okay? Because these are kind of hard and you might think you're doing right and you're doing them totally wrong. I think it's worth it, especially today on the notes and the short classwork assignment, that you really make sure you know how to do it before you start wasting a bunch of time doing your assignments totally wrong, not getting credit for them, getting really good at doing things the wrong way. You want to get good at doing it the right way. And the best way to do that is to figure it out right away. Okay? So try it out, do it, check your answers.